So for the second session, the topic is going to be immersive and tangible. It's going to be 3 presentations, 2 long papers and 1 short papers. So our first speaker is Dushani Perera, who is going to talk about Eco Garden. Dushani, over to you.
All right, so I'm Dushani Perera. I'm a PhD student at Cardiff University. So I'll talk about the data physicalization that we created, which is called Eco Garden, which is right behind me over here, that visualizes household consumption data. So to give a bit of context, households engage in daily practices such as watching TV, doing dishes, or doing laundry. But nearly 2/3 of global emissions are linked to such carbon-based such activities that households conduct, according to carbon-based accounting. However, people in households are not aware of how their actions can actually contribute to climate change. So to address this, we conducted a research to develop a data physicalization, particularly a data sculpture, to visualize household consumption data. So we did this research in 4 phases. I'll briefly go through the 4 phases. More details are in the paper. So we took a human-centered design approach here. So in phase 1, we explored household consumption practices, what challenges they face, and how they would like to visualize data. In phase 2, we conducted workshops to explore the design space. And in phase 3, we did the first version of the sculpture. And then finally, in phase 4, we did the final version of the sculpture. So in phase 1, we used 4 low-fidelity paper prototypes to conduct a survey study and 13 household workshops to understand people's challenges and how they would visualize data. And here we found certain design considerations, such as the physical artifact should be interpretable, it should be aesthetically pleasing, everybody in the house, including children, should be able to engage with it, etc. Based on these design considerations, we then created 5 low to medium fidelity prototypes and then conducted 15 household design workshops to collaboratively come up with a concept, a design for a data physicalization. So based on the findings we got here related to familiarity of objects, the personal connection people make with the objects, etc., we then created the first version of the sculpture. So it's got 3 discs, each for electricity, gas, and food waste. This selection also came from participants. So on each disc, there's a flower, as you can see over here. And on each flower, on one petal, there's a bee. So this functions as a traditional wall clock. The bee starts at 12 o'clock position in each disc and then rotates clockwise gradually throughout a week from Monday to Sunday to show the household consumption. And around each disc, there are these tiny flowers which are connected to an addressable LED. We did a complimentary mobile app on which people can set a weekly target for the consumption category, and that the LED corresponding to that value will be lit throughout the week. So the idea is not to let this bee rotate beyond this target value within the week. So then with these 2 first versions, we conducted 14 user feedback workshops. And then with the feedback that we got from the participants, we then modified the sculpture to the final version where the size is smaller and then the discs are color-coded by blue, yellow, and green. The colors are reflected on the app as well. The participants are able to choose the colors that they want for the discs, and also they can choose the colors they want for the LEDs. So there's some sort of adaptability there. And also the UI of the app is also modified according to the feedback. And then we conducted 15 household, we conducted a field study with 15 households where each house used the system for 3 weeks. So we did this from February to July this year. So on the paper, we report on the preliminary findings of this study. So we found that Eco Garden helped people to understand their consumption and reflect on how their activities can contribute to carbon emission. And also it motivated practice changes in the home to be more sustainable. So the main takeaway from this research is that there's a need to engage individuals and also households in an important topic such as climate change. Eco-garden is just one approach to design for sustainability, but it is an example of how physical manifestation allows adults and also children to contextualize sustainability in their personal life and collaboratively work towards environmentally friendly practices. Thank you very much.
Thank you so much, Dushani. Please save your questions for after the 3 talks are over. We have a slight change in the schedule. Nina is going to go first, and then we will hear from Rachel. Nina?
Yes, thank you so much. I'm going to share my screen. Let's see. Can you guys see my presentation?
We can.
Okay, great. So hello, everyone. My name is Nina Rosa. I'm a postdoc at Wageningen University and Research. And together with students from Utrecht University, we created an augmented reality app called Aware. And the paper I'm going to discuss is using handheld augmented reality for researching the potential of food resource information visualization. Well, I don't need to talk about climate change too much, but in the prospect of consumer behavior, there's still a huge attitude behavior gap, which is mostly a result of barriers that are experienced. One barrier in particular is psychological distance, so feeling that the problem and the consequences are very distant. This is spatially, temporally, hypothetically, and socially. And one example is from the food industry. We've kind of created food systems in such a way that psychological distance was bound to happen. We no longer really see our food being grown. We don't see it being processed or transported. And in this regard, virtual reality and augmented reality have been suggested as very good communication media that could help in, for example, learning, but also creating awareness, creating interest, and also changing behavior. So in this regard, I'd like to show 2 studies from in augmented reality and virtual reality. So this study was by colleagues of mine using augmented reality to understand the amount of food waste that is created in Dutch canteens. So this project was very data-driven to understand food waste on the one hand, but rather than creating this large Excel sheet that tells us X amount of breads were wasted, actually show the foods themselves to create a better understanding of what solutions could be used to solve this food waste. So that's in the now. And then looking at more future thinking, this study by Plechata and colleagues used virtual reality to let users create a meal. And then based on their selection in this meal, we could see the future of the Rocky Mountains 30 years from now. So using a more plant-based meal tends to show a very nice Rocky Mountain landscape, where a very high meat-centered meal shows the degradation of these Rocky Mountains. So using the potential of these, of especially augmented reality in this regard, we decided to create an application that could be used to tackle hopefully many of the problems that the literature is now showing in this area. Our application is called Aware. It's a smartphone application, and the aim was to let the user input a list of real foods or ingredients and then visualize the resources required to produce the food on their smartphone in their own kitchen. So what this means is that when the user opens the app, they have to scan their kitchen. And this just means the depth sensing on the phone, and they have to select surfaces on which they can visualize things. And then we see here an example of the app in use. This is in my own kitchen. So here I have an example of a meat-centered meal, a very simplified meal with pork and beets. So you see on the right-hand side, the pig that is used for the pork. We see near the center, the wheat plants that represent the feed that is required for the pig, and then the beets there next to the wheat plants. And then in the middle, we see the water that is required for all of these elements. So for the animals, the feed, and for the crops. And then in contrast, I have here a completely plant-based meal, which I call salad. It's an unusual salad, but it includes a bunch of different plants that can be shown in my kitchen. And then we see the smaller water requirements for all of these crops. So like I said, the idea of this application was to use it for future research directions. And I have a couple listed in the paper. I've categorized them, the first being experiences. So what we really want to understand is how the features of this implementation currently relate to the barriers that are experienced, in particular psychological distance. The reason we ask people to use this application in their kitchen is because it really connects the concept of food and their own actions together. And then the next step would be to perform a comparative study using AR in and out of a kitchen, but also augmented reality versus virtual reality, for example, or even a desktop version. With interventions, that would be the next step. So going beyond the barriers of, for example, psychological distance, we really want to study the effects on awareness, but also, for example, connectedness with nature, and also, of course, behavior change, because that's why we're here. And then next, interactions. So right now the experience is quite passive. I mean, besides having to input food that you might actually be using, there's no interaction between real and virtual. And we want to encourage people to interact with the virtual food, but also make connections with the real environment. So maybe they have to harvest their own crops, wash them in the sink, for example, and see whether these interactions actually amplify the effects that we saw in the interventions. And then lastly, there are some methodological aims. So in research, we're really seeing that we're lacking these longitudinal studies. The app is designed to be used in the home rather than in a lab, and we hope to facilitate these types of studies. But also we're looking into collaborating with online supermarkets to gain real data. So rather than gathering data on intentions, we measure more realistic behavior. That was it. Thank you. If you want to send me an email to ask more questions about that, there it is. And this project is also listed on GitHub for you to further develop and also download the application yourself. Thank you.
Thank you very much, Nina, for an inspiring talk. We have one last talk for this topic. Eleni is going to share the slides for Rachel. And Rachel, you can take over whenever you're ready.
Hi, yeah, good morning. My name is Rachel Connolly. I'm a research scientist at MIT in the Media Lab, and I work in the Future Worlds Research Initiative, and I'm here to talk about the Earth Mission Control platform that we've been working on developing. So next slide, please. Earth Mission Control recognizes that so much of our Earth observation data and climate variables are really measurable from space, but bringing together and knitting together all these various modalities of data can be very difficult. Next slide, please. Our goal is to really bring the data and the insights into some collaborative conversations and ultimately to action and decision making. And so we adopt a framework of going local, hyper-local to where you are, global to understand the bigger picture concept, and back to local for the decision making. So knitting the cohesive experience together with the data is really, this is our goal. So next slide, please. And could you hit the button one more time so the... Thank you. These are two videos of two case studies that we have developed so far, one on sea level rise and one on wildfires. And you'll notice that you're in an immersive experience where the actual climate impacts themselves are dynamic and motivating and affective in nature, but that then the different formats and modalities of data can be put together into one single environment. If you can go to the next slide, please. We have dashboards that allow you to control and bring up different kinds of data in the flat screen and interactive forms. We have a map table that allows us to go hyperlocal to particular places through different 3D models and maps. We have a globe that allows us to project spherical data sets. And then we have the dynamic scenic environment that it's all embedded in that sort of knits together the narrative. If you could go to the next slide, please. We also have a sandbox version of it. What we just showed was a more produced version that we do for demos, but this is the sort of student sandbox version where we can have multi-users get together around the table, go in real time to specific places, as well as work remotely with other scientists to, say, bring up particular data that they have to share right then and there. So we're really working on driving these conversations in real time for better collaboration and design. So if you could go to the next step, please. We've done user testing. Our three primary audiences are educators, and we do include the public in that in terms of their level of expertise. policymakers, and industry. We've done user testing that's really helped us understand the emotional response to the data, and the immersivity was really important, actually more forefront than background, we realized. The hyper-local climate data was really critical to, it's one of the things we're really working on, particularly through AI tools to help improve that hyper-local on-the-ground conversation. And then the interoperability and democratization of the data is the other thing that's been really critical to work on. So thank you for your time. Please feel free to connect. It is available at open source and on GitHub. If you'd like, please feel free to reach out and I can get you to it.
Thank you very much, Rachel. Thank you again to our speakers for this topic. Please, as per usual, raise your hand if you have any questions, want to make comments. You're all way too well behaved so far. We want a little bit more discussion, interaction. Don't be shy. We're happy to have these interactive discussions. I'm going to leave a little bit of an awkward silence for everybody to speak.
I have a question, but my raise hand doesn't work. So
perfect. Take over, Beth. Take over.
Oh, really very interesting work. And I was curious about, you said the emotional testing, which is always a challenge. And so I'm wondering if you can talk a little bit about, I look a lot at what are the emotional barriers that we raise to prevent ourselves from diving into topics. And so I was interested in your emotional testing, and if you could talk a little more about that and the results and how it impacts where you're going with the work.
Sure. I appreciate it. It's a really good question. I would say that initially when we started designing, we were really focused on, the different modalities of data with the map table and the, that type of thing. And we just wanted to have it embedded in a really contextual environment that was dynamic, that was consistent, with the different impacts that we were going to be telling the story about. So when we started to test it, though, with the different audiences, the first things they were saying is, whoa, the waters, like the fact that they were experiencing these impacts themselves, watching the fire come and impinge on the neighborhood, and that actually became that sort of initial and most important element to them. And in some cases, they were like, this is really intense. Now I want to know, like, it actually drove this, like, I want to know more about what this will mean for where I am, because then you go into a local place where it says, this is what wildfires have been increasing in this location, or sea level rise can be this in the next 5, 10, 15 years. So it actually helped drive that desire to almost want to know, what does this mean for where I live? And that urgency, and in some cases, some audiences, like younger audiences, were a little like the sound. We had to be careful with sensory overload for some audiences. So I would say that what it means is we're really going to be expanding our sort of library of what these impacts might really be like to experience in a realistic way, and marrying it with the kind of data that sort of backs up the what could look like in the future. So anyway, I hope that helps. It shifted from a background to a more forefront element of our design, if that makes sense.
Wow, we have all of a sudden plenty of hands up. I want to be mindful of time, but we're very happy to have the discussions going. Jessica, go ahead.
Yeah, I had a question along the same veins for Rachel. Did you find any overall differences between the three audiences in terms of their willingness to participate in the VR, and then their overall takeaways and experience in VR?
Great question. Willingness, not so much. I mean, they were really interested in the experience, but their takeaways were really different. And their focus was different. With industry, a lot of it has sometimes a lot of the industries, BP, Castrol, we work with large global entities often, and they're still interested often in bigger picture regional. They're not necessarily going to a particular location. They're looking at larger systems, and like their supply chain, how robust their supply chain is, things like that. So they have a different, more systemic view of things they're looking at, but through slices of things like how will it how will my real estate investments be, and things like that. So you have to do it more across sort of a construct or dimension, not necessarily a location. Whereas policymakers often are very specific to, like, what does this mean for my community or my district or my city? And so they need hyper-local, but also more socioeconomic or types of data that really the interoperability of the data there is critical. So I would say that they're all really excited to explore it, but their narrative and what they need for their conversations are very different. So sometimes it's forefronting that hyper-local design, and sometimes it's having more of a regional or bigger picture view, but for a key area of something they're working in. Does that make sense? I hope that helps.
Yeah, thank you.
Great.
What do you think the benefits are to go beyond the desktop? So in the case of physical visualization or immersive visualizations, what are the big pros of trying to go with these media compared to the more traditional desktop or mobile apps?
Thank you for the question, Fanny. So I think when it comes to screen-based visualizations, it's been there for ages now, and we don't spend much time on we spend too much time on the screens, which has made us kind of distance ourselves from, for example, maybe the apps that are provided by our energy providers. For example, that's what my participants said, that they don't really look at the apps. The charts are there, they show, okay, you spent £5 today, £10 today, but it doesn't really make any sense to me. So when it comes to physical visualizations, physical artifacts, they approach the user in more senses, where the screen-based visualization is just a visual, where the physical artifact would give you the touch. It could be auditory, it could be sound, it could be smell. So you can create a more sort of a personal attachment with it. And the other thing is, when it comes to a screen, you have to put in the effort of going into the screen, looking, like scrolling through the data, clicking buttons, looking at the data. So you have to like diverge your attention from whatever you're doing to going into the screen and looking and understanding your data. But when it comes to a physical artifact, it can just sit on your, maybe the kitchen, pantry top, or your desk. It can just be there in the periphery of your attention, and it wouldn't really bother you. But when you want to know your data, you can just look at it. And if you don't really want any distraction, you can just not have sound, not have lights. It can be just a movement, a shape-changing interface which gives you your visualization of data. So I think that is more closer to the people, and it can be less distracting. So it can be a good way of communicating the data.
Thanks, Dushani. Unfortunately, Nina had to go, so she cannot take the questions, but maybe we want to hear from Rachel on the benefits of beyond the desktop from your perspective.
That's a great question. I think for us, it's really creating the gathering around and the opportunity for co-creation and collaboration where the data is available and accessible, but not overwhelming. It's really how to better integrate a data-driven and informed decision-making and planning conversation that literally is more available to a wider variety of ages, audiences. That's why we're very careful about the data that we bring in. We've had a great partnership with NASA's Science Visualization Studio that makes beautiful, accessible imagery and visualizations. So the curating and the design and accessibility is really what's key. And just bringing them around the table, literally, is the goal. And we do have a version of it that is desktop accessible. You do not need to be in headset to join it. And so that's really what it is, trying to bring people together and around the table. I hope that helps.
Thank you, Rachel.
Sure.
Please, the audience, if you have answers also to these questions, more general questions that we ask, feel free to partake in the discussion We still have a little less than 10 minutes for discussion, so I invite more comments and participation. Eleni?
Fanny, we have a few questions from Slido.
Yes, please.
So one question is from Anna Offenwanger. Echo Garden, how is the data collected for the visualization?
All right. So for EcoGarden, we've got electricity data, gas data, and food waste data. So for electricity, we used TP-Link Tapo P110 smart plugs. So we asked our participants to pick the top 10 devices that they use on a regular basis at home and use the smart plugs to collect the electricity data of those appliances. And that I collected through a relay system that I have inside EcoGarden, which is a Raspberry Pi based relay system. So that sends the data to my backend. For food waste and gas, the mobile app that we created, on that people have to enter themselves. They have to report their food waste and also self-report their gas data as well. For gas, of course, in the UK, it's very difficult to tap into an automated gas reporting system. I couldn't really find one. For food waste, I was initially trying to have maybe a weight sensor or something in the food bin, but I couldn't really go through with it. So both of those are in the app. I think it answers the question, Anna.
I think so. She's sitting right beside me. Bridger, please. Go ahead.
Yes, great. Hi, Bridger Herman, Carleton College in Minnesota. So I have a question for all of our speakers, actually. So I'm really interested. So like having done work in virtual reality and physicalization and all of this, there's a lot of work that goes into building these individual applications, right? So I'm curious to all of your takes on ways that we might scale these solutions up to being used in broader audiences and all of that. So particularly on the physical side and also on the virtual side.
I think I can have a go. So yeah, that's actually a very good question. So taking the prototype to the production stage, I think that's what you're, So that's something that I was thinking as well. So for example, once we built this, it didn't take long. I think it took like a week or so, but all the laser cutting and even getting the materials and how sustainable are the materials. Like we tried to go for wood as much as possible, but then the inside, there are 3 layers. There are 2 layers which are acrylic. So the sustainability of the materials and how are we going to scale this was actually a problem. So how we thought of approaching it, we haven't done that yet, but our plan is to kind of have a concise circuit where, I mean, currently I'm using 3 microcontrollers inside this and a Raspberry Pi. That's not the best circuit, to be honest, but I reckon I can just do all of that with just the one Raspberry Pi. And also thinking about the cost of it, just recently there was this workshop. I wonder if you come across prototype to production, device prototyping to production sort of a workshop where they extensively spoke about this. So yeah, I mean, going forward, our plan is to think about the sustainability of the physicalization as well as mass producing them in a smaller scale with using the minimum number of circuits that I could use to just visualize the data that I want in the way that people would expect. I wonder if that answered the question.
Yeah, certainly on the physical end. I'm curious, Rachel, if you could speak to the virtual end of things, like developing assets for all of these different simulations. Certainly must take a lot of time, does take a lot of time, and like how that might scale to broader applications.
Yeah, I have 2 quick answers, but then it's a bigger important conversation. So thanks for bringing it up. In the experience of EMC itself, or Earth Mission Control, one of the things that we're working on is advancing sort of how the hyper-local data can be identified and responsive in through more AI tools. I mean, we know that that's going to be really critical to help get people ultimately towards, right now we still work on developing case studies for a place, but getting in and saying, let's go to a place in real time, that's sort of like more responsive experience. We're going to be working towards and using AI tools. Another thing beyond Earth Mission Control is that we have other tools in our sort of toolkit. One of them is called Climate Pocket, which is it's a phone app development that allows you to see physics informed future views of, in one case, flooding in particular areas. So how to have something that's more immediate and very specific in narrative on your phone, so it doesn't have to just be in the VR experience. So I'd say those are the two answers, how to make the virtual reality one more responsive right there, immediate through AI tools, and then how to make other tools that can be beyond the VR experience for looking at the future in a trusted way. Sorry, Mark?
Okay, thanks.
Mark,
Yeah.
I'm going to let Mark do this too.
Just some thoughts on scaling up the sort of VR experience. And honestly, I think one of the reasons we haven't done as much work in the VR space is precisely that, is that it tends to be the kind of solitary experience. One thing we did with the Earth Information Center that Lanny was talking about initially is we have an immersive room. So this is a way to create a group experience inside of sort of the 360 environment. They're still kind of small, the number of people we can get in there. We're building bigger ones. But one thing I'd advocate for if you're developing VR type applications is look at planetariums. These are like built-in immersive spaces where you can set a couple hundred people and maybe not do everything you can do in VR, but bring a lot of the experience there.
I think Nagas had a question earlier.
Sure. So this is a question for Rachel. It seems that you're working with a massive amount of global data. My question is, do you have a way to dynamically update this data, or is it bound to a specific time frame?
Great question. The answer is it depends a little bit on the data. We do have through APIs the ability to plug into, air quality, some data that you can show on the dashboards in near real time, or as it comes in, that you can pull it down. But it is a little bit dependent on the data or the amount of contextualization and scaffolding needed to understand the data, given that you have to sort of make sure you're integrating it sort of seamlessly into the experience overall. But that's a great question. So yes, you can with some data.
All right, folks, thank you so very much. We're reaching the time for the little break.